What is multimeter? A multimeter is a portable tester used to test resistance, voltage, and other electrical quantities. They are available in analog and digital variants. When diagnosing electrical issues with motors, appliances, circuits, power supply, and wiring systems, they are one of the tools electricians favor. Types of multimeter. 1. Analog multimeter. An analog multimeter has a needle that swings across a graded scale and is based on a microammeter, which measures amperage or current. Although less expensive than their digital counterparts, analog multimeters might be more challenging for certain users to read precisely. They need to be handled carefully and can be broken if dropped. Analog multimeters are excellent for spotting slow voltage changes. Due to their low resistance and high sensitivity, analog testers excel when used as ammeters. 2. Digital multimeter. Digital multimeters come in both basic and complex designs for electronics experts. Digital meters display readings on an LCD screen rather than the analog meters moving needle and scale. Digital multimeters are often superior to analog in the voltmeter function. Easy to read and incredibly precise digital readout is the main benefit of digital testers, and now, let us talk about the parts of multimeter. We have here the needle/pointer, scale, 0 ohm adjuster, ports, negative test probe, adjustment screw, range selector knob, range, and positive test probe. 1. Needle/pointer, the needle-shaped rod that moves along a meter scale. It displays the multimeter's measured values. 2. Range selector knob, selector switch, allows you to change the function and range of the meter. 3. Adjustment screw, it allows you to move the pointer to the scale's 0 position. 4. Scale, it is a set of marks used to read the value of a quantity. 5. Negative/positive test probes, to connect the circuit to the electrical components being tested. Positive, red, and negative, black, wires are used. 6. 0 ohm adjuster, it is used to zero in the pointer before measuring resistance. Let us have now the parts of a digital multimeter. We have display, buttons, negative test probes, dial/rotary switch, input jacks and positive test probes. The first part is the display. It is the place to see measurement readouts. The second one is buttons, which is used to select various functions, model-specific choices. Third one is dial or rotary switch, which is used to choose the initial measurement values, volts, amps, ohms. The fourth one is input jacks, which is placed to insert test probes. And lastly, the test probe, which is the same as the analog multimeter, is used to connect the circuit to the electrical components being tested. Positive, red, and negative, black, wires are used. How to use multimeter. Both digital and analog testers use a multimeter, which has similar fundamental operations. 3 ports and 2 leads, red and black, are present on the tester. The common port accepts the black lead as a plug. Depending on the intended function, the red lead can be inserted into one of the other ports. After connecting the leads, you turn the tester's center knob to choose the function and suitable range for the particular test. You connect each lead's pointed, bare metal end to the terminal or wire that has to be tested in order to get a reading. If the voltage or current does not exceed the tester's maximum rating, multimeters can be safely used on powered circuits and machinery. Additionally, you must take care to avoid touching the tester lead's bare metal ends when performing an energized test, because doing so could result in an electrical shock. How to read the multimeter. 1. Choose the appropriate scale for your analog multimeter. The needle indicates the result on analog multimeters. Note, resistance is measured using the ohmega scale. Usually, the top of the scale is the largest. DC voltage is read using the DC scale. You can read AC voltage using the AC scale. Resistance reading, look for the ranges where the pointer is pointing. Note, each line has different value. Make sure the pointer is pointing to the 0 mark. Understand the different value according the ranges. Range 0 to 2 have a line value equal to 0.2, range 2 to 10 have a line value equal to 0.5, range 10 to 20 have a line value equal to 1, range 20 to 50 have a line value equal to 2, range 50 to 100 have a line value equal to 5, range 100 to 200 have a line value equal to 20. Range 200 to 300 have a line value equal to 50, range 300 to 500 have a line value, 100 and so on. For an example, the pointer points in between 10 to 20. We understood that the value of the line in between the range 10 to 20 is 1. So therefore, the answer is 12 ohms. Second example, the pointer points in between 50 to 100. The value of the line in between 50 to 100 is 5, so the answer is 60 ohms. And lastly, the pointer points in between the ranges 2 to 10, the value of the line in between the said ranges is 0.5, therefore the result is 3 ohms. Note that the given answer are the partial result because we have to multiply the result to the multiplier to get the actual resistance reading. If the knob point to 10K as the multiplier, the given result should be multiplied to 10K. As what is seen in the picture. For an example, the 12 ohms, which is the partial result based on the first example, will be multiplied to 10K. Therefore, the actual resistance reading is 120,000 ohms/120K ohms. The second example, 60 ohms, which is the partial result, will be multiplied to 1K. Therefore, the actual resistance reading is 60,000 ohms/60K ohms. And lastly, 3 ohms, which is the partial result, will be multiplied to 10. Therefore, the actual resistance reading is 30 ohms. Reading voltage, 1. Set your range selector knob to the highest range in your multimeter. Note, this is to protect your multimeter for being damaged. 2. Know the ranges where the pointer is pointing. AC for red marks and DC for black marks. Let US have an example, alternating current. The needle is pointing at a thick line. If the range selector knob is selecting 10, therefore the actual voltage reading is 8 volts. If the range selector knob is selecting 50, therefore the actual voltage reading is 40 volts. If the range selector knob is selecting 250, therefore the actual voltage reading is 200 volts. Remember again to look at the scale with red marks. Now let US have an example with direct current. Note, use the black marks in the scale to get the value with direct current. Example 1. If the range selector knob is selecting 10, therefore the actual voltage reading is 4 volts. If the range selector knob is selecting 50, therefore the actual voltage reading is 20 volts. And lastly, if the range selector knob is selecting 250, therefore the actual voltage reading is 100 volts.